These are the test corrections for the domain and range test. Remember, you are working out the ones you got wrong on a separate sheet of paper. And for these, since there's not a lot of work to be done, you're going to need to explain for each one what you did wrong. Why did you get the answer you did? What misconception did you have? How do you know it's right now? Okay, so for number 1, we have a graph that says a student rode a bike from school to a rec center. And the graph is showing us the distance in miles after riding the bike for X minutes. So the first thing I notice is I have endpoints here. It is continuous data. It is a function, but it doesn't go on forever because I have endpoints. So the next thing I need to look at is range. Range is the Y, so that's over here. So I'm looking at this part of the graph here. Okay, the lowest Y value I have is right here at 0, and the highest is right here at 9. So that's all real numbers greater than or equal to 0 and less than or equal to 9. Okay, a lot of people miss this one because they picked D, and that's not true because I don't have negative numbers here. Like -1 is less than 9, but that's not possible here. So when we take like a linear function and use a real world situation, then we have like boundaries for our range. It can't just be everything. Okay, so number 2, which graph represents a function with a domain, so x, of all real numbers greater than or equal to -7 and less than 2. So greater than or equal to -7, I'm going to need closed circle. And less than 2, at 2, I'm going to need an open circle. And then it's kind of like everything in between. And I'm looking on my x. So I might go through and do that so I don't end up looking at y's. Well, this goes from -2 to +7, so it's not A. And this one goes from -3, so it's not B. And this one goes from -4, so it's not C. So it must be D. Let's make sure. It goes from -7 to 2, and I have an open circle on 2, so D is the correct answer. Okay, number 3 shows you a picture of a golfer who hit a ball. The, whatever that is, a tree box, is 6 yards above the ground. The graph shows the height in yards as a function of x. Okay, so they want to know the domain. Okay, it is continuous, so we have all these inequalities. Domain is x, so automatically it can't be B or C because those have y's here in the middle. Okay, so I need my x values. There's a lot of numbers on here. Maybe that's confusing, so I'm going to cross off the y values here. And then I see that my x goes from 0 to 230. These are closed, so I need less than or equal to signs. 0 to 230. This point would only be important if we were talking about the range, okay, because that would be the maximum value for y. So A is our correct answer here. I think if people got that wrong, they were looking at the 6. So it might be easier to cross out those numbers we don't need to look at. All right, number 4. A set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair of plates weighs 20 pounds. If X pairs of plates, so those are our X values, are added to the barbell, the total weight of the barbell in plates and pounds can be represented by that function. And we want the range. So I want the Y. I want the output. I'm looking for the f of x. Okay, so I see it's discrete because I don't have unlimited amounts of weight plates. I'm only going to 6, and I can't put like half a plate on there or a quarter of a plate. That wouldn't make sense. Okay, so I can only go to 6, so that tells me that my x values, my options for x, or I could put 0 weight plates on there. I could put 1 pair, 2 pair, blah, 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 all the way up to 6 pairs. Okay, so I need to know that so that I could figure out f of x. These are the numbers you're putting in there for x. If it asked for domain, this would be your answer, but it didn't. It asked for range. So I'm going to do 20 times 0 plus 4, which is going to give me 4. And then 20 times 1 plus 4, which is going to give me 24. And then 20 times 2 plus 4, which is going to give me 44, etc. And B is going to be my answer. Okay, so for these ones, you're going to have to figure out, it's kind of like that cookie dough problem we did. You have a certain amount of containers of cookie dough, and you get a profit per container. So to figure out what your output is, you have to put your input into your function and evaluate it, follow order of operations, and that's what gives you your output, or your y, or your f of x, or your range. Okay, number 5, part of the function is graphed on the grid, and I need to find the domain. So again, looking at the x, I need to see my minimum value. Well, that's going to be right here, and my maximum value kind of goes on forever. So if I look, that's why I don't have those like double inequalities. I just have one. I'm looking for domain. We already said that's x, so it can't be b or d. I see that my x value minimum is -2, and it is filled in, so that's going to be greater than or equal to, because it's going this way, which is increasing. So your correct answer is A. Okay, number 6, another graph shown. I need to find the range, so that's my y value. So I'm looking here. Oops. Okay, the first thing I notice is I have an open circle and a closed circle. That's going to be important. So my minimum y value is here, and my maximum is here. So I'm going from -5 to +3. I need y in the middle. And then this is just less than, because it's open circle. That's less than or equal to, because it's closed circle. So if I look here, I don't have y's, I have f of x's. That is the same thing. Y, f of x, output, all the same thing, range. Okay, so it can't be A or B. So when I look, I just gotta make sure I have the open circle taken care of there. So it's C. Okay, and then this last one. So this function here will graph like this, and if I made a set of tables, a set of values, and I put those x values in, that is what I will get out for y. The question here really is this continuous or discrete? Remember, discrete is individual points. So Jackson would have looked at this table and said, well, those are individual points, so it's going to be discrete. But if this is my function and there's no real life situation to attach this to, I could put anything in for x. It's going to be all real numbers. Okay, so it is going to go on forever. And so that's why my domain is all real numbers. Okay, the range does end, let me sort of make this bigger, here. The minimum point for the y value is, minimum value is -7. So that range is correct. Okay, now, it is continuous, but lots of people told me it was continuous because it goes on forever. No, I'm okay with saying that when you say the domain is all real numbers because of the arrows and it goes on forever, true. It's continuous, though, not because it goes on forever, but because you could put smaller numbers in there for x fractional pieces. That's why it's continuous, okay? Because any number works for x, including fractions, decimals, things like that, okay? So he is correct here. Tyler is correct, okay, because it is a discrete, it is a continuous function, because you could put anything in there for x. You could put 0.123, square it, multiply it by 0.5, and subtract 7 and get the y value back out, and it would be a point on that curve. Okay, this, if he was just going off of here on Jackson's side, if he's just going off this table, okay, we can understand if he thought it was discrete, that would be right and that would be right. It doesn't matter what order these are in, etc., but it's not discrete, okay, because we have that function, and any function you have, if you just have a random, not really random, but you know what I mean, if you just have a function, I could put anything in there for x I wanted to. So that includes fractions and such. Okay, so that's why it's not discrete, because all numbers work for x. Oops. And the biggest thing I saw here was, like I said, lots of people told me it was continuous because it has arrows and goes on forever. That is not what makes a graph continuous in math. Okay, remember, continuous means fractional pieces will work for the input. Okay, so if you have a function with no constraints on, like, you know, like we had a function for the weight plates in number 4, the weight plates, that's a function. So if it was just a function, then yes, it would be continuous. But because I'm applying it to the situation where we have those weight plates, and you cannot put a fractional piece of a weight plate on there because you're not going to be breaking them in half or whatever, then then at that point it becomes discrete. Okay, so don't forget to explain what you did wrong on each of these, because there's no really necessarily work to be shown, and then you have to make sure all your homework's done, and most of you have all that done, those 2 sheets that cut and paste. Whether or not you cut and paste is fine, and then the escape the classroom. And the only way you wouldn't have that done is if you were absent, so CB, and we'll figure out when you can make that up, or if you just forgot to hand it in. Okay, and then I will post what days I'm available for retest.